Welcome to this video. I'm Physics and today we are going to be going over series circuits. So first of all, what is a series circuit? A series circuit is an electrical circuit which only has one path for the current to flow through. So the charge conservation in a series circuit. The principle of charge conservation states that the total electric charge stays the same in a closed system. This leads on to Kirchhoff's first law, where the total current flowing into the junction is the same as the total current flowing out of the junction. Due to this, the current in a series circuit is the same everywhere in the circuit. So a remembering hack is SCPV, where S equals series and C equals current, and P equals parallel and V equals voltage. So SC means that in a series circuit, the current is going to be the same, and PV states that in a parallel circuit, voltage is going to be the same. So, energy conservation. The principle of energy conservation states that energy cannot be created or destroyed but transferred, so the total energy in the closest circuit stays the same. This and the charge conservation leads on to Kirchhoff's second law, which states that the sum of all voltages in a series circuit is equal to the battery voltage, or the sum of all the voltages in a loop is equal to 0. Due to the energy conservation in a series circuit, the battery PD is shared across all the components in the circuit, so the total sum of the voltages in the components add up to the battery voltage. Combining resistances. In a series circuit, the total resistance in the circuit is equal to all the resistances of the resistors in the circuit. So now we are going to be going on to the GCSE example exam style question, where it states, add the voltmeter to the circuit which will measure the potential difference voltage across the heater. So we know that a voltmeter is used to measure potential difference or voltage, and as it says across the heater, we will need to draw a voltmeter parallel to the heater, as you can see here. As voltmeters are never in series, they are always parallel to the component that they are measuring the potential difference of. So in this case, it's the heater. So now II states that calculate the potential difference across the heater. So we are given the resistance, which is 15 ohms, and the current, which is 0.56 amps. So we know the formula is V equals IR, and so we just need to multiply them together. So 15 times 0.56, and that will equal to 8.4 volts. So now we are going to be going on to the A-level example exam style question, where it states that student used the LED with a 5 volts of power supply as shown in the circuit. To be lit to normal brightness, the current through the LED must be 18 milliamps. Calculate the resistance of the resistor needed in the circuit. So, as we know, the current going through the LED is 18 milliamps. We can find the voltage going through the LED using the graph on your screen here. So on the y-axis, we need to find 18, and we need to go across, and we have to go down. And so the voltage going through the LED will be 2 volts. And due to SCPV, we can see that in a series circuit, the voltage is different. So it won't be 2 volts. And as the power supply has a voltage of 5, you can just do 5 minus 2, which is 3 volts. So 3 volts is going through the resistor. And also due to SCPV, we can see that the current going through the series circuit is going to be the same everywhere. And so the current going through the resistor will also be 18 milliamps. And so we can find the resistance using the formula V equals IR. But we need to rearrange it for the resistance. So BV over I equals R. So we need to do 3 divided by 18, but as it's milliamps, we need to times it by 10 to the power minus 3. So 18 times 10 to the power minus 3, and that will give you 166.7 ohms, and that's the answer. Don't forget the unit as it's not given in the question. You'll lose marks if you forget it. So now we are going to be going on to the other A-level example exam style question, where it states derive the formula for the total resistance RT for the circuit in terms of R1, R2 and R3. So SCPV. So as we know, in a series circuit, the voltage is going to be different. So we can write it as E equals V1 for resistance 1 plus V2 through resistance 2 plus V3, which is through resistance 3. And so as V equals IR, we can write IR instead of the V's and the E's. And as SC, we can see that I is going to be the same for all of them as they're in series. So IRT equals IR1 plus IR2 plus IR3. And we can just cancel out the I's as they are going to be the same. And so we are going to be left with RT equals R1 plus R2 plus R3. Sorry, that's a 3. And there you have it. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.